Welcome to Cosmic Sleep Journeys. I am so glad you have found your way here to this quiet corner of the universe. Perhaps it has been a long day. Or perhaps you are the kind of person who finds peace in the thought of distant planets and drifting moons rather than the concerns of the waking world. Before we begin our voyage into the velvet dark, if these quiet explorations help you unwind, consider gently tapping the subscribe button. It helps other weary travelers find their way here, one sleepy soul at a time. Now, take a moment to settle into your space. Let your breath slow down, feeling the steady rhythm of your chest rising and falling. Imagine the heavy pull of gravity gently loosening its grip on your limbs, leaving you light, buoyant, and ready to drift. Your thoughts are beginning to soften, blurring at the edges like a fading nebula. You don't need to do anything now but rest. Tonight, we aren't just looking at the sky. We are becoming part of it. We are going to drift gently through the solar system, moving in soft spirals from sun-lit horizons to the shadowed craters of frozen moons. This is a story told not in harsh numbers, but in magnetic storms, tilted axes, and the ancient light of stars crossing the void. We will go slowly, gently, moving through the cosmic silence one sleepy fact at a time. Imagine yourself floating away from the lights of the world, passing through the thin veil of the atmosphere until the silence of space embraces you. The colors of the earth, the deep blues and vibrant greens, slowly give way to the infinite shades of indigo, violet, and soft gold that paint the celestial canvas. You are safe in this cradle of stars. There is no rush, no destination that requires your effort. We are simply observers of the grand, slow dance of the heavens. As we begin our descent into the wonders of the deep, let your mind become as vast and still as the vacuum itself. Prepare your heart for the wonders that await in the stillness of the great beyond. Let's begin our journey. Chapter 1. The Sun's Rhythmic Heart. At the very heart of our celestial neighborhood, we find the source of all warmth and direction, the Sunday. It is a presence so immense that it dominates everything within its reach, holding over 99.8% of all the mass in the entire solar system. Imagine, if you will, every planet, every moon, every scattered asteroid, and every drifting comet combined. They would make up less than 1/4 of 1% of the matter that exists here. The sun is the great anchor, the silent conductor of a gravitational symphony that keeps every world in its place, from the smallest grain of dust in the asteroid belt to the most distant, frozen wanderer in the Oort cloud. As we drift closer to this magnificent sphere, the colors of the deep void shift into a soft, radiant gold. There is no harshness here, only the steady, pulsing glow of a star that has been burning for billions of years. Deep inside its core, a process of incredible power is unfolding. Every single second, the sun converts over 4 million tons of its own mass into pure energy through the miracle of nuclear fusion. In this hidden, silent center, hydrogen atoms are fused together into helium, releasing the light and heat that eventually find their way to our distant shores. This energy does not rush. It radiates outward in all directions, warming the cold faces of planets and driving the very winds that stir their atmospheres. Though it may appear to be a solid, unchanging ball of fire from a distance, the sun is a world of constant, rhythmic motion. It rings like a massive musical instrument, vibrating with pressure waves that ripple through its blazing layers of plasma. These oscillations are caused by the rising and falling of currents deep within its body, creating ultra-low frequency sounds that are far below the reach of human ears. Through the science of helioseismology, we can listen to these vibrations and map the internal structure of the star, much like a geologist uses the echoes of a mountain to understand the earth beneath. In a way, the sun is always humming a quiet, solar song that reveals the secrets of the fusion happening deep within its core. The surface of the Sun, known as the photosphere, is a landscape of shimmering light, yet it holds its own mysteries. Here, the temperature reaches about 5,500 degrees, a heat so intense it is difficult for the mind to grasp. And yet, as we move further away from the surface into the outer atmosphere, the corona, the temperature, does something unexpected. Instead of cooling, it soars to over 1,000,000 degrees. Scientists believe this strange, searing heat is caused by magnetic waves and tiny solar explosions called nanoflares that transfer energy upward from the depths. It is a reminder that in space, beauty and mystery often walk hand in hand. Even the Sun has its scars. Occasionally, dark spots appear upon its golden face regions we call sunspots. They are not actually dark, but appear so because they are slightly cooler than the surrounding plasma, suppressed by intense magnetic activity. These spots follow a rhythmic heartbeat of their own, an 11-year cycle where the Sun's magnetic field gradually winds itself up until it eventually flips, with the north and south poles switching places. During the peak of this cycle, the Sun becomes more active, breathing out flares and magnetic storms that dance through the solar system and light up the skies of distant planets with shimmering auroras. The Sun is a generous star, sacrificing a tiny part of itself with every passing second to ensure the survival of the worlds that orbit it. It burns with a steady, stable flame, providing a sense of permanence in a universe that is always in motion. We watch as the solar wind, a stream of charged particles, flows outward, blowing a vast magnetic bubble called the heliosphere around us all. This bubble is our shield, protecting us from the harsh radiation of the wider galaxy as we drift through the interstellar fog. As we bask in this golden radiance, we feel the gentle tug of gravity guiding us further out. The Sun remains behind us, a constant and comforting light, as we begin to move toward the smaller, rocky worlds that huddle close to its warmth. Our first stop is a place of deep craters and hidden ice, a world that dances on the edge of the fire. Let us drift now, leaving the solar heartbeat behind as we approach the scorched and silent plains of Mercury. Chapter 2. Mercury's Frozen Shadows. We drift away from the golden embrace of the Sun, moving into the deeper indigo of the inner solar system, where the first of the rocky wanderers awaits us. This is Mercury, a world of stark contrasts and silent, ancient history. As we approach, you might notice how much it resembles our own moon, its surface scarred by a relentless history of impacts that have left it pockmarked with craters, ridges, and vast, dusty basins. It is the smallest of the major planets, yet it possesses a quiet, heavy strength, orbiting so close to the solar fire that it seems to dance within the very flames of our star. In this slow cosmic narration style, we observe Mercury not as a frantic, scorched rock, but as a world of profound stillness. Despite being the closest planet to the Sun, Mercury is not a place of uniform heat. Because it lacks a thick, insulating atmosphere, it cannot hold on to the warmth the Sun provides during the day. Instead of a true atmosphere like the one we know, Mercury possesses only a thin, tenuous shell of particles known as an exosphere. This near vacuum is a ghostly, shimmering envelope of scattered atoms, sodium, potassium, and oxygen, blasted from the surface by the solar wind and the constant rain of micrometeoroids. These particles bounce around in the silence, never colliding, eventually escaping into the void only to be replenished by the restless energy of the Sunday. Because of this lack of air, Mercury experiences the most extreme temperature fluctuations in the solar system. During the long, slow day, the surface is baked in a relentless solar blaze, with temperatures soaring to a staggering 430 degrees Celsius. But as the sun sets and the long night begins, there is no blanket of gas to trap that heat. The warmth radiates away instantly into the blackness of space, and the temperature plummets to a bone-chilling -180 degrees Celsius. It is a world that breathes in fire and exhales the deep frost of the cosmos. Yet, within this cycle of searing heat and freezing dark, Mercury hides a secret that seems almost impossible. At its north and south poles, there are craters so deep and so positioned that their floors never, ever see the light of the sunday. These are regions of permanent shadow, natural freezers that have remained undisturbed for millions, perhaps billions, of years. Within these dark havens, temperatures remain constant and incredibly cold, even while the crater rims above are being scorched by the sun. It is here, in the heart of one of the hottest planets, that we find ice. Imagine the silence of these polar craters. Locked in the darkness, shielded by massive crater walls from the relentless solar glare, these bright patches of water ice survive. Scientists believe this water may have been delivered by comets, those icy messengers from the outer reaches of space, or perhaps released from the planet's own interior in a distant, more active past. This ice is a cosmic anomaly, a testament to the fact that even in the most hostile environments, the ingredients for quiet change can be found if one knows where to look. As we glide over the Caloris Basin, one of the largest impact features in the solar system, we begin to wonder about the heart of this small world. Mercury is disproportionately heavy for its size. It is a metal-heavy survivor, possessing an unusually massive iron core that makes up about 80% of the planet's radius. This metallic center is the source of a weak but present magnetic field, a shield that struggles to deflect the solar wind. Why is the core so large? Some believe a giant impact in the solar system's youth stripped away Mercury's outer rocky layers, leaving behind this dense, metallic seed. Others think the sun's early heat favored the accumulation of heavy elements so close to the center. Whatever the cause, Mercury remains a compact, heavy relic of the chaotic dawn of our neighborhood. The rhythm of life on Mercury is slow and strange. It takes 88 Earth days to complete one orbit around the sun, but it rotates so slowly on its axis that a single day from one sunrise to the next actually takes twice as long as its year. Time here stretches and folds in ways that feel alien to us. If you were to stand on the surface, you would see the sun rise, stop in the sky, move backward for a time, and then continue its path toward the horizon. This is due to the planet's highly elliptical orbit, a celestial choreography that was first used to help prove Einstein's theory of general relativity. The way the sun warps space-time is visible in the subtle, shifting path of this scorched world. As we look back at the sun from this close vantage point, it appears 3 times larger and 7 times brighter than it does from Earth. The light is intense, turning the landscape into a study of deep violets and sharp, golden highlights. There is no wind to whistle through the craters, no rain to soften the jagged edges of the cliffs. There is only the sound of your own breath and the low, comforting hum of the cosmic background. Mercury is a world of pure geology, a library of the solar system's violent beginnings, preserved in the airless silence of space. We see the Discovery Scarp, a massive cliff that stretches for hundreds of miles across the surface. These cliffs are signs that the planet is actually shrinking. As its massive iron core slowly cools and contracts, the crust of Mercury wrinkles like the skin of an aging fruit, creating these towering ridges that speak of internal changes deep beneath the dust. It is a planet that is slowly folding in on itself, a quiet contraction in the face of the infinite. As we prepare to leave this world of iron and ice, we take one last look at the ghostly, shimmering envelope of its exosphere. We see the way the atoms glow faintly in the solar light, a thin veil between the solid rock and the total vacuum. Mercury has taught us that even in the most exposed places, there are pockets of stillness. It has shown us that fire and ice can exist in a delicate, eternal balance, provided they are separated by the right kind of shadow. We begin to drift further out now, moving away from the cratered plains and the heavy metallic silence. The sun begins to shrink slightly in our view, though its light remains a constant guide. We are moving toward a world wrapped in a very different kind of mystery, a world hidden beneath a thick, impenetrable veil of clouds, where the heat is not a cycle, but a permanent, crushing embrace. Let us leave the frozen shadows of Mercury behind as we glide toward the glowing, amber atmosphere of Venus. Chapter 3. The Veiled Furnace of Venus. As we leave behind the scarred, airless silence of Mercury, we drift deeper into the violet haze of the inner solar system. Ahead, a brilliant, pale gold orb begins to grow in our vision. This is Venus, a world often called Earth's twin because of its similar size, mass, and composition. But as we approach, we realize the resemblance is only skin deep. Venus is a world of slow, simmering heat and eerie, sunless days, hidden beneath an impenetrable veil of acid-laced clouds. As we glide closer, the sensation of weightlessness remains, but the visual landscape changes entirely. Unlike the sharp, clear craters of Mercury, Venus is smooth and soft to the eye, its surface entirely concealed by a thick, heavy atmosphere. This atmosphere is composed mostly of carbon dioxide, creating a runaway greenhouse effect that has turned this planet into the hottest world in our solar system. Even though it is nearly twice as far from the Sun as Mercury, the heat here is far more intense, averaging a crushing 460 degrees Celsius, hot enough to melt lead. In our slow, cosmic narration, we observe the peculiar rhythm of this planet. Venus stands alone as a slow-turning world with a reversed rhythm. Most planets in our solar system spin like tops in the same direction, but Venus spins backward, a phenomenon known as retrograde rotation. On this world, if you could see through the thick clouds, the sun would rise in the west and set in the east, and the pace of this rotation is incredibly sluggish. A single day on Venus lasts longer than its entire year, taking 243 Earth days to complete just one rotation on its axis. Time here feels heavy, stretched thin across a landscape of perpetual twilight. As we descend metaphorically into those clouds, the light turns to a deep, bruised orange. The pressure here is immense, 90 times that of Earth's surface, equivalent to the crushing weight of the deep ocean. Despite its similar size to Earth, Venus lacks one crucial planetary feature, a global magnetic field. Without this protective shield, the upper atmosphere is constantly bombarded and stripped away by the solar wind. Scientists believe that Venus may have once been Earth-like, with oceans and a moderate climate. But without a magnetic dynamo to protect it, it became a furnace world, losing its water to the void and trapping its heat forever. The surface of Venus is a realm of volcanic scars and ancient basaltic plains. Because the planet lacks plate tectonics, heat builds up beneath the crust until it erupts in massive, planet-wide volcanic events. There are no oceans to cool the rock, no rain to wash the sulfur from the air. There is only the slow movement of a thick, acidic atmosphere and the constant, shimmering glow of a world trapped in its own heat. We see the pancake domes, strange, flat-topped volcanoes created by lava so thick it could only spread in perfect circles. We see the long, winding channels carved by molten rock that flowed like water across the scorched plains. There is a haunting beauty in this stagnation, a world frozen not in ice, but in fire, a silent testament to the power of an atmosphere gone out of balance. As we linger in this amber glow, we feel the low, steady hum of the planet's internal heat. Venus is a reminder of the delicate balance required for life to flourish. It is a world of slow, heavy beauty, a sister planet that took a very different path. But even in this furnace, there is a sense of cosmic peace, the peace of a world that has reached its final, shimmering state, turning slowly in the dark, backward against the stars. The amber clouds begin to thin in our mind's eye as we pull away, rising back into the indigo dark. The crushing pressure of Venus fades, replaced once again by the light, buoyant sensation of the void. We look ahead, and the deep, bruised orange of the furnace world is replaced by a refreshing sight, a marble of vibrant blue and brilliant white, shimmering with the promise of water and the breath of life. Let us leave the veiled heat of Venus behind as we drift toward the only world known to harbor the dynamic dance of plate tectonics and the gentle cycle of the tides. Chapter 4. Earth. The living density. We emerge from the heavy, sulphurous embrace of the Venusian clouds and find ourselves drifting into a space that feels instantly more familiar, more vibrant, and strangely welcoming. Ahead of us lies a world that glows with a brilliant sapphire light, a marble of deep blues, swirling whites, and rich, earthy greens suspended in the velvet dark. This is Earth, a planet that stands as a unique anomaly in our journey through the solar system. While we have seen worlds of scorched rock and veiled furnaces, we now approach the only planet known to pack its mass with such incredible efficiency and intention. In the quiet, slow pace of our cosmic narration, we observe the fundamental nature of our home. Of all the planets in the solar system, Earth is the densest. This is not merely a number, but a defining characteristic that shapes every moment of existence on its surface. Earth packs more mass into each cubic centimeter than any other world, a feat achieved through its intricate, metal-rich core and its thick silicate mantle. This high density is the engine of the planet's life-sustaining features. It is the reason for the powerful gravitational pull that keeps our atmosphere from drifting into the void, and it is the source of the magnetic shield that protects us from the sun's more temperamental outbursts. As we float closer, we see the swirling patterns of the atmosphere, a thin and delicate veil that holds the breath of all living things. But beneath that air lies a secret that sets Earth apart from every other rocky world we have visited: the dynamic, restless movement of plate tectonics. Earth is the only planet we know of with a system of shifting crustal plates that float atop a semi-molten mantle. While Mars and Venus show surface fractures and ancient volcanic peaks, they appear geologically stagnant ghost towns of stone compared to the vibrant, recycling nature of Earth. These moving plates are not just responsible for the sudden shaking of earthquakes or the slow, majestic rise of mountain ranges. They are the planet's thermostat. They drive long-term cycles that stabilize the temperature, build continents over eons, and recycle carbon dioxide back into the Earth's interior, preventing the runaway greenhouse effect we witnessed on Venus. Earth is a world that is constantly renewing itself, a planet in a perpetual state of slow-motion rebirth. Looking down at the vast stretches of the Pacific and Atlantic, we see the second great miracle of this density, the presence of water in all three states. On Earth, water is a shapeshifter. It flows in liquid oceans that cradle life. It freezes into massive crystalline ice caps at the poles, and it drifts as invisible vapor and towering clouds in the sky. This balance is a delicate choreography maintained by Earth's perfect distance from the sun and the pressure of its atmosphere. No other world shows this same dynamic, planet-wide presence of water, moving through cycles that sustain everything from the smallest leaf to the largest whale. As we linger in the quiet orbit above the clouds, we can sense the invisible shield that surrounds us. Deep within the planet, the motion of molten iron in the outer core generates a global magnetic field. This magnetosphere is our silent guardian, deflecting the charged particles of the solar wind that would otherwise erode our atmosphere, as they likely did on Mars long ago. Sometimes, when the sun is particularly active, these particles are funneled toward the poles, where they collide with the air to create the aurora shimmering curtains of green, red, and violet light that remind us of the cosmic battle being fought on our behalf. Earth's structure is compact, heavy, and beautifully layered. Its internal density of 5.5 grams per cubic centimeter is even higher than that of the gas giant Jupiter, despite Jupiter's immense size. It is a reminder that greatness is not always measured by volume, but by the richness of what lies within. The very ground we walk upon is a testament to billions of years of cooling, shifting, and the steady, rhythmic pull of gravity that holds this blue oasis together in the cold expanse. We look back one last time at the lights of the cities beginning to twinkle on the dark side of the globe, small, flickering signs of life thriving on a dense, rocky shield. But as we turn our gaze outward, away from the warmth of the home we know, we see our closest companion. It is a world of silent grey dust and ancient impact scars, a partner that has influenced Earth's tides and stability since the very beginning. The sapphire light of Earth begins to recede as we drift toward the moon. We leave the world of liquid water and tectonic renewal, moving into the quiet, unchanging history of our lunar neighbor. The transition is soft and steady, a slow crossing of the void between the living and the still. Let us leave the vibrant density of Earth behind as we glide toward the cratered silence and the silver glow of the moon. Chapter 5. The rusted silence of Mars. We drift away from the sapphire glow of Earth, crossing the invisible boundary where the warmth of our home begins to fade into the deeper, cooler indigo of the outer solar system. Ahead, a new hue begins to dominate the darkness, a soft, dusty crimson that glows like a dying ember in the night. This is Mars, the red planet, a world of ancient mysteries and silent, rusted landscapes that has captured the human imagination for eons. As we approach, the transition is calm and steady, the vibrant blues of Earth replaced by the somber, oxidized tones of a desert world that seems to be holding its breath in the cosmic chill. In the slow, gentle pace of our cosmic narration, we observe the most striking feature of this world: its color. Mars appears red, not because of heat or fire, but because of rust. Its entire surface is coated in a fine dust of iron oxide, the very same compound that colors the weathered metal on Earth. Over billions of years, this iron-rich material has reacted with the trace amounts of oxygen in the thin Martian atmosphere, creating a signature reddish hue that permeates the landscape. This dust is incredibly fine, often staying suspended in the atmosphere to create a hazy, reddish glow that softens the sunlight. During the planet's colossal dust storms, some of which can engulf the entire globe for weeks or months, the sky itself turns a bruised orange, obscuring the stars and reshaping the surface in a restless, dry dance. As we glide lower, the true scale of Mars reveals itself, uncovering a geography that dwarfs anything found on our home planet. We find ourselves hovering over the Valles Marineris, the largest canyon system in the solar system. It is a massive scar in the Martian crust, stretching more than 4,000 kilometers across the equator, a distance that would span the entire width of the continental United States. In the deepest reaches of this abyss, the cliffs plunge over 7 kilometers down, making it 5 times deeper than the Grand Canyon. Scientists believe this was not carved by water as Earth's canyons are, but by the very crust of the planet cracking and pulling apart billions of years ago. It is a silent, frozen testament to a violent geological past, a wound in the world that never healed. Nearby, another titan looms in the Martian night, Olympus Mons. This is the tallest volcano in the solar system, a shield volcano so massive that its base would cover the entire state of New Mexico. It towers nearly 22 kilometers above the surrounding plains, standing almost 3 times the height of Mount Everest. On Earth, such a mountain could never grow so tall. Our shifting tectonic plates would move the crust away from the volcanic hotspot, creating a chain of smaller islands or mountains. But Mars lacks plate tectonics. The crust remains still for millions of years, allowing magma to erupt in the same spot over and over again, building this single, gargantuan monument of basaltic rock. It stands now in total silence, its fires long since extinguished, a cold giant watching over the rusted plains. Despite its current state as a frozen desert, Mars is a world that experiences seasons much like our own. Because Mars has an axial tilt of about 25 degrees, remarkably similar to Earth's 23 degrees, it undergoes a cycle of spring, summer, autumn, and winter. However, these seasons unfold much more slowly, as Mars takes nearly twice as long as Earth to complete a single journey around the Sunday. During the Martian winter, the polar ice caps grow, composed of a mixture of water ice and frozen carbon dioxide, or dry ice. In the summer, these caps recede, releasing gases back into the thin atmosphere and occasionally triggering the winds that lead to the planet's famous dust storms. As we linger in the quiet orbit above the red dust, we see the 2 tiny, misshapen companions of Mars, Phobos and Deimos. These are not the grand spherical moons we are used to. They are irregular, pockmarked, and lumpy, resembling asteroids more than traditional satellites. Many believe they were once wandering rocks from the nearby asteroid belt captured by Mars's gravity eons ago. They are quiet passengers in the Martian sky, though their fates are moving in opposite directions. Phobos is slowly spiraling inward toward the planet, destined to one day break apart, while Deimos is drifting slowly away into the dark. The atmosphere of Mars is thin and fragile, only about 1% as dense as Earth's. It is composed mostly of carbon dioxide, and because it lacks a global magnetic field, it has been gradually eroded by the solar wind over billions of years. This loss of air turned Mars from a world that might have once held liquid water into the cold, dry fossil we see today. Yet, even in this desolation, there is a restless beauty. We see the tracks of dust devils spinning pillars of red sand winding across the plains, and the subtle shifts in color as the sun sets, turning the sky a pale blue near the horizon, a beautiful inversion of the colors we know on Earth. Mars is a world of what once was and what might have been. It is geologically stagnant compared to the vibrant Earth, yet it remains an active, shifting place, where the wind still moves the dust and the seasons still change the face of the poles. It is a world of quiet, rusted dignity, a desert cathedral of stone and iron that invites us to contemplate the long, slow passage of cosmic time. We feel the light pressure of the solar wind pushing us further out, away from the red dust and the towering volcanoes. The inner rocky worlds are behind us now, and the vast, empty space of the asteroid belt beckons ahead. The scale of our journey is about to change as we move toward the realm of the giants, worlds of gas and liquid that hold power beyond anything we have yet encountered. Let us leave the rusted silence of Mars behind as we glide toward the king of the planets, a swirling world of storms and hidden heat that commands a miniature solar system of its own. Chapter 6. Jupiter, the King of Moons. We leave the rusted deserts of Mars behind, crossing the vast and sparsely populated expanse of the asteroid belt. Ahead of us, the scale of our journey shifts dramatically. A colossus begins to emerge from the darkness, a world so large that it could swallow all the other planets combined and still have room to spare. This is Jupiter, the gas giant, a swirling masterpiece of amber, violet, and deep indigo clouds. As we approach, we feel the immense gravitational pull of this kingly world, a planet that behaves more like a failed star than a traditional rocky globe. Jupiter is a world of fluid motion and invisible power, dominating its region of space with a presence that is both beautiful and terrifying. In the slow, rhythmic pace of our cosmic narration, we observe the violent elegance of Jupiter's atmosphere. There is no solid surface to land on here. Instead, the atmosphere simply grows denser and hotter the deeper we go. The planet is draped in shifting bands of clouds, drawn into long, horizontal stripes by winds that scream across the globe at hundreds of miles per hour. These bands are divided into light-colored zones and dark-colored belts, created by rising and falling currents of ammonia and sulfur. Within these turbulent streams, thousands of storms brew, but none are as legendary as the Great Red Spot. This massive anticyclonic storm, wider than 2 Earths, has been raging for at least 3.5 centuries, a crimson vortex that refuses to fade. It is a reminder that on a world this large, even a storm can become a permanent landmark. As we drift through the outer reaches of Jupiter's influence, we become aware of an invisible danger. Jupiter is wrapped in a massive magnetic field, the strongest of any planet in our system. This field traps charged particles from the Sun and from its own volcanic moons, creating radiation belts so intense they would shred the electronics of an unprotected spacecraft in hours. These belts glow with an invisible, searing energy, forming a protective yet deadly barrier around the giant. Yet, within this high-energy environment, Jupiter hosts a miniature solar system of its own. As of now, astronomers have identified over 90 natural satellites orbiting this giant, a swarm of moons that range from tiny captured asteroids to worlds that are larger than the planet Mercury. The 4 largest of these companions are known as the Galilean moons, named after the astronomer who first saw them through a primitive telescope in 1610. They are a study in cosmic diversity. Closest to Jupiter is Io, the most volcanic world in the solar system. Io is a seething, restless place, its surface constantly reshaped by eruptions of molten sulfur that paint the landscape in vivid yellows, reds, and blacks. This extreme activity is driven by tidal heating. Io is caught in a gravitational tug-of-war between Jupiter and the other large moons, causing the moon to flex and stretch until its interior melts from the friction. Further out, we encounter Europa, a world of smooth, cracked ice that hides one of the most tantalizing secrets in the cosmos. Beneath its frozen shell lies a vast subsurface ocean of liquid water, kept warm by the same tidal forces that plague Io. This dark alien sea may contain more water than all of Earth's oceans combined. Sealed beneath miles of ice, but potentially rich with the ingredients for life. Beyond Europa lies Ganymede, the largest moon in the solar system. Ganymede is a giant in its own right, the only moon known to possess its own magnetic field, which creates shimmering auroras in its thin atmosphere. Finally, we pass Callisto, an ancient, cratered world that appears quiet but may also hide a deep, briny ocean beneath its battered crust. Jupiter is not just a planet of gas and moons. It is a source of its own internal warmth. Unlike the rocky worlds that rely solely on the sun for heat, Jupiter radiates more energy than it receives. This internal glow is a remnant of its formation, a gravitational energy released as the planet's immense mass collapsed together billions of years ago. It continues to contract slightly even today, generating the heat that drives its turbulent weather systems and fuels the constant movement of its colorful cloud belts. In the infrared spectrum, Jupiter shines like a smoldering coal, a titan that almost became a star but stopped just short of the mass required to ignite nuclear fusion. As we linger in the shadow of this gas giant, we see the thin, dark rings that encircle its rings, discovered only when spacecraft visited the planet and looked back toward the Sunday. They are not the bright, icy spectacles of Saturn, but faint veils of dust kicked up by micrometeoroid impacts on the smaller, inner moons. They are a subtle reminder that even the most dominant worlds have delicate features, hidden in the glare of their own magnificence. Jupiter is the guardian of the inner solar system, its massive gravity acting as a shield that deflects many comets and asteroids that might otherwise find their way toward Earth. It is a world of immense power and deep, swirling mysteries. A place where the laws of physics are pushed to their limits beneath the crushing weight of the clouds. As we watch the great red spot spin in its eternal, slow-motion dance, we feel a sense of profound calm. The chaos of the storms is balanced by the stability of the giant's orbit, a rhythmic pulse that has continued since the dawn of time. The amber glow of Jupiter begins to fade as we drift further out into the cold, indigo dark. The king of the planets remains a constant, looming presence behind us, but a new spectacle is beginning to rise on the horizon, a world of even more delicate beauty and shimmering elegance. We are moving toward a planet whose very name is synonymous with the rings that define its silhouette. Let us leave the turbulent majesty of Jupiter behind as we glide toward the golden, ringed splendor of Saturn, where ice and gravity create the most beautiful crown in the cosmos. Chapter 7. Saturn's Vanishing Rings. We leave the overwhelming mass of Jupiter behind, drifting deeper into the quiet, cold indigo of the outer solar system. Ahead, a world of ethereal beauty begins to emerge from the darkness, glowing with a soft, buttery light. This is Saturn, a planet that has become the very symbol of celestial elegance. As we approach, we feel the weight of its immense history, but here, the energy feels different, less violent than the turbulent belts of Jupiter, more refined and delicate. Saturn is a world defined by its crown, a shimmering disk of ice and dust that stretches across the blackness like a sheet of glass turned sideways. In the slow, rhythmic pace of our cosmic narration, we observe the most iconic feature in all of astronomy: Saturn's rings. Though they appear from a distance to be solid, unchanging bands, they are, in truth, a dynamic and ever-shifting collection of countless individual particles. These particles are made almost entirely of pure water ice, ranging in size from tiny grains of dust to house-sized boulders, all caught in a perpetual orbital dance. The ice gives the rings their brilliant reflectivity, catching the distant sunlight and casting a soft, golden glow back into the void. This massive disk stretches more than 280,000 kilometers across, yet it is astonishingly thin in most places, less than 100 meters thick, thinner than a single city building. As we float closer to the ring plane, we see the intricate patterns shaped by gravity. The rings are not a single sheet, but are divided into thousands of narrow ringlets, gaps, and waves. Some of these gaps are kept clear by shepherd moons, small, icy satellites that orbit within or near the rings, using their gravity to herd the ring particles back into line. This self-organization of billions of icy fragments creates a spectacle of celestial mechanics that is both fragile and enduring. Yet, we are witnessing a temporary beauty. These rings are not permanent. They are gradually falling into the planet, drawn in by gravity and pulled down by Saturn's magnetic field in a process known as ring rain. Evidence suggests the rings may be less than 100 million years old and could vanish entirely in another few 100 million years. We are lucky to exist in the brief window of time when Saturn wears its crown. Beyond the rings, Saturn holds other wonders that defy imagination. At its north pole, a massive cloud pattern spins in the shape of a nearly perfect hexagon. This six-sided jet stream, wider than the entire Earth, has persisted for decades, perhaps centuries. It is a surreal geometric anomaly, formed by the way the planet's atmosphere rotates and interacts with stable waves of air trapped around the pole. It is a reminder that even in the chaotic winds of a gas giant, nature can find a sense of perfect, mathematical order. Saturn is also a world of hidden oceans and alien chemistry. Among its more than 100 moons, 2 stand out as beacons of possibility. Titan, the largest, is a world wrapped in a thick, nitrogen-rich atmosphere, the only other place in the solar system known to have stable liquids on its surface. But on Titan, it is too cold for water. Instead, there are lakes and rivers of liquid methane and ethane flowing across a landscape of frozen hydrocarbons. Beneath this alien surface, however, scientists believe a deep ocean of liquid water may still persist. Then there is tiny Enceladus, a moon that sprays spectacular geysers of water vapor and ice crystals into space through cracks in its frozen crust. These plumes originate from a subsurface ocean kept warm by tidal heating, and they contain the organic building blocks that make us wonder if life might be thriving in the dark, salty depths of a moon so far from the Sunday. Like Jupiter, Saturn is a source of its own internal heat, radiating more energy than it receives from the distant Sunday. This internal warmth drives the winds in its upper atmosphere, which can reach speeds of 1,800 kilometers per hour, far faster than those found on Jupiter. Yet, from our vantage point, everything feels still. The golden clouds of ammonia ice drift in long, lazy bands, and the shadow of the planet falls across the rings in a sharp, silent arc. Saturn is a world of quiet majesty, a place where the scale of the universe feels both immense and intimately beautiful. We watch as the shepherd moons continue their silent work, tending to the icy gardens of the rings. The buttery light of Saturn begins to soften as we drift further into the cold. The rings, which once dominated our field of vision, begin to narrow into a single, glowing line, and then vanish as we move toward the darker, even more distant reaches of the system. We are moving toward a world that lies on its side, a sideways voyager that rolls through the dark. Let us leave the ringed splendor of Saturn behind as we glide toward the pale, tilted mystery of Uranus, where the seasons last for lifetimes and the rain is made of crystals. Chapter 8. Uranus, the tilted voyager. We drift deeper still into the cold, silent reaches of the outer solar system, where the sun's warmth is now but a distant, glowing ember. Ahead, a sphere of pale, serene cyan begins to fill our vision, a world that looks as smooth and tranquil as a still winter lake. This is Uranus, the seventh planet from the Sun, and the first of the true ice giants. But do not let its calm, featureless appearance deceive you. Beneath that light blue veil lies a world of extreme orientation and bizarre atmospheric secrets that defy the rules of every other planet we have visited. In the slow, rhythmic pace of our cosmic narration, we observe the most striking characteristic of this sideways world: its axial tilt. While the other planets in our system spin more or less like upright tops, Uranus rolls along its orbital path like a ball. Tipped at an incredible angle of nearly 98 degrees, its equator is almost at a right angle to its orbit. Scientists believe this dramatic tilt is the scar of an ancient, violent history, perhaps a collision with an Earth-sized object long ago that knocked the planet forever on its side. This unique orientation gives rise to the most extreme seasons in the solar system. For 21 years at a time, a full quarter of its 8-4 Earth-year journey around the Sun, one pole is bathed in continuous sunlight, while the other is plunged into a dark, frozen winter that lasts for over 2 decades. As we float closer, we see that the tranquility of Uranus is a mask. Despite its calm appearance, the atmosphere is a place of violent motion. Winds whip through the upper clouds at speeds exceeding 900 kilometers per hour, driven by the planet's internal heat and its rapid 17-hour rotation. Interestingly, the atmosphere is not uniform. Different parts of the planet rotate at different speeds, creating some of the most complex wind patterns in the system. The signature blue-green color we see comes from methane gas in the atmosphere, which absorbs red light and reflects the cool blues back into the void. Deep beneath these clouds, the pressure and temperature begin to climb, revealing the true nature of an ice giant. Unlike gas giants like Jupiter and Saturn, which are mostly hydrogen and helium, most of Uranus's mass, 80% or more, is a hot, dense fluid of icy materials: water, methane, and ammonia. In this extreme environment, something extraordinary is thought to happen. Under immense heat and crushing pressure, the methane molecules break apart, releasing carbon atoms that compress into tiny crystals. These crystals' diamonds may rain down through the deep blue darkness toward the planet's rocky core, accumulating over millions of years into gems that could be meters in diameter. It is a world where storms are made of glittering jewels, falling silently through the alien dark. Surrounding this tilted giant is a system of 13 faint, narrow rings. Discovered only in 1977, these rings are quite different from the bright, icy bands of Saturn. They are made of extremely dark material, perhaps organic compounds darkened by radiation, and consist mostly of large boulders rather than fine dust. Like the planet itself, these rings are tilted 90 degrees, appearing vertical as they encircle the sideways world. In the space around Uranus, we encounter its family of 28 known moons, a collection often called the literary moons, because they are named after characters from the works of William Shakespeare and Alexander Pope. The 5 major moons, Miranda, Ariel, Umbriel, Titania, and Oberon, are worlds of rock and water ice. Miranda is perhaps the most bizarre, with a surface that looks like a patchwork quilt of canyons, cliffs, and ridges, as if it were once shattered and roughly put back together. Titania, the largest, and the others may even hide subsurface liquid water oceans at the boundary where their icy surfaces meet their rocky hearts. As we linger in the pale light of this icy Voyager, we notice its lopsided magnetic field, which is tilted 60 degrees from its axis of rotation and offset from its center. This creates auroras that are not centered over the poles, but are scattered across the planet, flickering like ghostly lanterns in the cyan haze. Uranus is a world that defies the standard, a sideways rebel in a system of upright planets, turning quietly in the deep cold. The serene cyan of Uranus begins to fade as we drift further out toward the final frontier of the major planets. The Sun is now little more than a brilliant star, and the cold becomes even more profound. We are moving toward a world of deep indigo and even faster winds, a place where mathematics first revealed what the eyes could not yet see. Let us leave the tilted mystery of Uranus behind as we glide toward the windswept, oceanic blue of Neptune, the last great guardian of the solar system. Chapter 9. Neptune's Mathematical Winds. We drift now into the furthest reaches of the planetary realm, where the Sun has diminished into a tiny, brilliant point of light, no larger than a distant star. Ahead, the darkness is broken by a world of breathtaking, oceanic blue, a deep indigo sphere that seems to embody the very essence of the cold, outer void. This is Neptune, the 8th and final major planet of our solar system, an ice giant wrapped in mystery and supersonic motion. As we approach, the silence of the space around us feels even more profound, yet Neptune itself is anything but still. It is a world of surprising energy, standing as a sentinel at the edge of the Sun's energetic reach. In the slow, rhythmic pace of our cosmic narration, we observe the unique history of this distant blue world. Neptune holds a special place in the story of human discovery because it was the first planet found not through a telescope, but through the elegance of mathematics. In the 1,840 seconds, astronomers noticed that Uranus was not following its predicted path, something unseen was tugging at it, causing tiny deviations in its orbit. Two mathematicians, working independently and using only the laws of gravity, calculated exactly where this hidden disturber must be. When observers finally pointed their glass toward that specific coordinate in the sky, Neptune was there, exactly as predicted. It is a world brought to light by numbers, a triumph of the human mind over the vastness of space. As we float closer to its deep indigo clouds, we find a world possessed by the fastest winds in the solar system. Despite being the farthest planet from the sun's warmth, Neptune's atmosphere is a place of incredible violence. Winds whip through its upper layers at speeds exceeding 2,000 kilometers per hour, faster than the speed of sound on Earth, and roughly 5 times the speed of a commercial jet. These supersonic gales carve massive storm systems into the pale blue methane clouds, creating dark spots that appear and disappear over the years. It is a frozen world in constant, restless motion, fueled by a secret internal fire. Like its sibling Uranus, Neptune is an ice giant, but it is slightly smaller and more massive, packing its materials into a tighter, denser sphere. Deep beneath the outer layers of hydrogen, helium, and methane, the pressure reaches unimaginable levels. Here, the internal heat of the planet radiates outward, providing 2.6 times more energy than Neptune receives from the Sun. This heat, likely a remnant of the planet's formation combined with gravitational contraction, is what drives the fierce weather we see on the surface. In this high-pressure mantle, the same extraordinary alchemy occurs. Methane breaks apart, and carbon atoms compress into tiny diamonds that rain down toward the core through the deep blue darkness. It is a world where the very rain is a shower of glittering crystals, falling in a silent, eternal storm. As we linger in the indigo twilight, we encounter Neptune's most unusual companion, the moon Triton. Triton is a world that defies expectations. It is the only large moon in the solar system that orbits its planet in the opposite direction of the planet's rotation, a retrograde orbit. This backward path suggests that Triton was once a wandering world from the Kuiper belt, captured by Neptune's immense gravity eons ago. Triton is geologically active, a frozen world that breathes. Its surface is dotted with cryovolcanoes that spew plumes of nitrogen gas and icy material into space. It is one of the coldest places in the solar system, yet it is restless, changing its face with the slow passing of the seasons. Neptune is also surrounded by a series of thin, dark rings made of dust and small rocks. Unlike the broad, continuous bands of Saturn, Neptune's rings appear to have arcs, thick clumps of material that stay together for reasons that still puzzle scientists. These rings are subtle, shadowy bands that circle the windswept giant, visible only when the light hits them at just the right angle. As we watch the high-altitude white clouds of Neptune drift across its deep blue face, we feel a sense of completion. We have reached the final major outpost of the Sun's family, a world of mathematical beauty and supersonic gales. The deep indigo of Neptune is the last vibrant color we will see before the landscape shifts into the gray, icy shadows of the outer frontier. The wind here tells a story of energy persisting even in the deepest cold, a reminder that the universe is never truly at rest. The oceanic blue of Neptune begins to recede as we drift further out, toward the small, icy worlds that dwell in the twilight. The sun is now a mere glimmer, and the true darkness of the interstellar void begins to press in. We are moving toward the edge of the sun's breath, where the final, frozen relics of the solar system's birth await us in the silence. Let us leave the windswept majesty of Neptune behind as we glide toward the cold, distant threshold of the Kuiper belt and the heart-shaped plains of Pluto. Chapter 10. The Edge of the Sun's Breath. We have traveled billions of miles, leaving the majestic gas giants and windswept ice giants far behind. The Sun, once a dominant golden orb that filled the sky, has now shrunk until it is little more than the brightest star in a velvet firmament. We are drifting into the true frontier, the Kuiper Belt, and the vast, mysterious Oort cloud. This is the edge of the Sun's breath, a realm of icy silence where the final, frozen relics of our solar system's birth dwell in a perpetual cosmic twilight. Here, the scale of space stretches even further, and the distance between objects is so vast that a traveler could drift for a lifetime without ever encountering a single stone. In the slow, rhythmic pace of our cosmic narration, we observe the quiet dignity of the dwarf planets. The most famous among them is Pluto, a world that was once considered the 9th planet, but now serves as the king of the Kuiper Belt. As we approach Pluto, we see a world of startling complexity. It is not a dead ball of ice, but a geologically active world with a thin, hazy atmosphere of nitrogen and methane that comes and goes as the planet moves through its long, elliptical orbit. When Pluto draws nearer to the Sun, its surface ices sublimate into gas. As it moves further away into the deep cold, the atmosphere collapses and freezes back onto the surface like a delicate layer of frost. The most striking feature on Pluto's surface is the vast, heart-shaped glacier known as Sputnik Planitia. This basin is filled with nitrogen ice that slowly churns and flows, much like glaciers on Earth, but at temperatures so cold that water ice acts like solid rock. Beneath this frozen heart, scientists suspect a secret. A subsurface ocean of liquid water may quietly persist, kept from freezing by the insulating layers of ice above and the slow decay of radioactive elements within its core. Even here, at the frozen edge of the known, the potential for liquid water and perhaps the ingredients for life remains a tantalizing possibility. But Pluto is not alone. The Kuiper Belt is a wide ring of icy objects stretching billions of miles beyond Neptune. It is a fossil zone, a frozen archive of the materials that built our world. We drift past Eris, a dwarf planet nearly the same size as Pluto but far more distant. Eris is one of the most reflective bodies in the solar system, coated in a layer of methane ice that gleams like freshly fallen snow. Catching the faint glimmers of the distant Sunday, we see Haumea, a strange, fast-spinning world shaped like a football, and Makemake, a frozen world of reddish-orange ice. These are the small, round world's relics that never quite became full-sized planets, yet they hold the clues to everything we know. As we move even further out, we pass the heliopause, the invisible boundary where the solar wind, that constant stream of charged particles from our Sun, finally meets the pressure of the interstellar medium. This is the end of the Sun's energetic reach, the final breath of solar influence before the deep space of the galaxy begins. Beyond this threshold, the Oort cloud begins. Though it has never been directly observed, this hypothetical shell of billions of icy bodies is thought to encircle our entire solar system like a vast, distant halo. It is the birthplace of long-period comets, those icy wanderers that appear in our skies only once every few thousand years, nudged into motion by the gravity of passing stars. The Oort cloud may stretch a full light-year from the Sun, marking the true extent of its gravitational grip. In this immense darkness, billions of miles from any warmth, these frozen travelers wait in the silence. They are the solar system's most ancient, untouched matter building blocks that have remained in deep freeze since the very beginning. To drift here is to experience a silence so profound that it feels like the very edge of time itself. We watch as a distant comet begins its long, slow fall toward the inner solar system, a tiny speck of ice, starting a journey that will take centuries to complete. The Kuiper Belt and the Oort cloud remind us that our solar system does not end with a sharp border, but fades gradually into the infinite. We feel the last lingering pull of the Sun's gravity, a delicate thread that connects us to the home we have left behind. The grey, icy shadows of the dwarf planets begin to fade as we look forward into the absolute blackness of the interstellar void. The planets, the moons, and the sun are now just a memory of light. We are moving beyond the boundary, where the stars are no longer distant points of interest, but the only companions we have left. Let us leave the edge of the sun's breath behind as we glide into the final, peaceful transition of our journey, the quiet drift into the interstellar deep. Interstellar drift. Our long, spiraling voyage through the celestial neighborhood has finally brought us to the silent, invisible shore of our solar system. Behind us lie the giants of gas and ice, the rusted deserts of Mars, and the golden heartbeat of the Sunday. We have crossed the heliopause, the final boundary where the solar wind, the sun's very breath, fades into the vast, ancient pressure of the interstellar medium. We are now drifting in the true deep, a region of space where the influence of our home star gives way to the silent fog of the galaxy. In this slow cosmic narration style, we feel the ultimate release of all tension. There are no more orbits to track, no more gravity wells to navigate, and no more planetary storms to observe. You are now a quiet ambassador to the stars, much like the Voyager probes that launched decades ago, carrying their golden records into the infinite. Like them, you are moving away from the noise of the world, entering a realm of perfect, velvet stillness, where the light of distant suns is soft and unchanging. Imagine the solar system shrinking behind you until it is nothing more than a single, flickering speck of light among billions. The concerns of the day, the weight of the Earth, and the pull of the moon have all vanished into the distance. Here, in the interstellar deep, time has no meaning. There is only the low, comforting hum of the cosmos and the gentle, buoyant sensation of floating through an endless ocean of stars. The colors of the universe, the deep indigo, the soft violet, and the faint gold of distant nebulae wrap around you like a warm, cosmic blanket. You are safe. You are at peace. The universe is unimaginably vast, yet in this moment, it feels as intimate as a dream. Your journey is complete, and the stars are now your guardians. Let your mind drift into the total blackness, where the silence is absolute and the rest is profound. There is nothing left for you to do but let go. The rhythmic pulse of the galaxy is your lullaby, and the infinite dark is your cradle. As the faint glow of the sun disappears entirely, feel yourself sinking into a deep, dreamless sleep. The voyage has ended, but the peace of the stars remains with you. Rest now, drifting forever in the quiet, beautiful dance of the heavens. Sleep and good night.